What's the ratio? Yeah, you're just comparing two things. That's all we're doing. So in number 6, what is the ratio of the mass of oxygen atoms to sulfur atoms? Okay, so we are going to compare the mass of this to the mass of this. Oxygen to sulfur. So how would we write that out? 16 to 32. And do we leave it that way in math? What do we tend to do? Reduce it. We simplify it. So it would be what? 1 to 2. Okay. And so over here in the table, we have ratio of masses of atoms. That would be 1 to 2. Ratio of numbers of atoms. So number of atom in the sample, we have 1 oxygen atom, we have 1 sulfur atom. So what would be the ratio of our numbers of atoms? 1 to 1. Okay. All right, so number 7, fill in the table in Model 2 in a similar fashion to the eggs table in Model 1. Divide the work evenly among the blah, blah, blah. Reduce all ratios to their lowest whole number. So what we're going to do is we're just going to fill this in. All right. So if we have 1 atom, and 1 atom is 16 atomic mass units. So let's just say 16 grams. It's kind of all the same thing. If 1 oxygen atom is 16 grams, what's the mass of 10 oxygen atoms? 160. I just multiply, right? So that's what we put in the table. That's easy enough. 160. And if I have 10 sulfur atoms, what will be the mass of those sulfur atoms? 320. All right. All right. So now, what's the ratio of the number of atoms? What's the ratio of the number of atoms? Pay attention to my words. Number of atoms. What's the ratio? 10 to 10, which reduces to 1 to 1. All right, and then now we want to get the ratio of the masses of the atoms. Still 1 to 2, because it's 160 to 320, which reduces 1 to 2. All right, so now what if we have 1 dozen? That's 12, so 12 times 160. Might want your calculator handy. What's 12 times 160? I don't know. 192? Okay. Thank you. You're correct. I was wrong. It should be 16 times 12. Thank you. Is 192. Okay. And so now we got to do 32 times 12, which is 384. So, what's the ratio of our number of atoms? Still 1 to 1. And what's the ratio of our masses? Still 1 to 2. Because if I take 192 and divide it by 184, I get 2. I said that wrong. 192 divided into 384 is still 2. All right, look at the next one. 1,000,000. 16 with 6 zeros behind it. Six million. And what about the next one? 32 with 6 zeros behind it. All right, so what's our ratio of number of atoms? Still 1 to 1. 1,000,000 divided by 1,000,000 is still 1 to 1. And what about ratio of masses? Still 1 to 2. All right, what about 1 mole? Now, 1 mole is way bigger than a million. Because remember, we said 1 mole is 6.022 times 10 to the 23rd of things. So if I have 1 mole, that is equal to 16 grams. 1 mole is always equal to whatever that thing's atomic mass is, which you get off the periodic table. Okay? So 1 mole is 16 grams of oxygen. 1 mole of sulfur is 32 grams of sulfur. What's the ratio of our atoms? Number of atoms? Still 1 to 1. What's the ratio of our masses? Still 1 to 2. Okay? Circle the phrase below that completes the sentence. When 2 samples contain the same number of atoms, what? The masses of the samples will be equal. The ratio of the sample masses will be equal to the ratio of the atomic masses. The masses are unrelated. So which one of those sentences fits? If 2 samples contain the same number of atoms, not mass, pay attention to my words, or contain the same number of atoms, what can you say about their masses? That their masses are equal? That the ratio of their masses equal the ratio of the atoms' masses? Or their masses are unrelated? The middle one is correct. Okay? So, 1 mole and 1 mole. That's equal as far as the number of things there. And so how that translates to the masses, the ratio of their masses will be the same as the ratio of the individual atoms' masses. Okay? So number 9, explain why it is not necessary to know how many atoms are in 1 mole to finish the last row. I told you how many there were, but why would it not matter? Because they still have the same what? No matter how many things are in a mole, you still have the same number of things in the mole. So their masses are still going to be the same ratio. You don't need to know what that number necessarily is. You just know that they have the same number of things in them, and the ratio of their masses will be the same. All right. What do you think about number 10? What do you think the correct answer for number 10 would be? Exactly. Everything, the ratios would stay the same. It would be 1 to 1 for the number of them. And so, yeah, it would still be 1 to 1. Because the ratio of their masses has stayed the same. The ratio of their masses is still 1 to 2. So that means the ratio of the number of things present would still be 1 to 1. All right, number 11. In the front of a room, there's a bottle that contains 32 grams of sulfur. This is 1 mole of sulfur. Estimate how many atoms are in the bottle. There are 32 grams of sulfur in the bottle, and that's 1 mole. How many atoms would that be? Let's say this is a bottle of sulfur, not alcohol. And in this bottle, I have 32 grams of sulfur, which is 1 mole of sulfur. How many atoms would that estimate? How many atoms would that be? You got a good memory, I already said it once or twice. you don't have a good memory, look back up here at your table. Look at the table. The row above 1 mole is 1 million. And we're getting bigger every time, right? As we go down. So if this is 1 million, 1 mole has got to be greater than, less than, equal to 1 million? What? Greater than. So we know at least that much. So what do you want to estimate if you can't remember the exact number? Huh?
More than
That's kind of a broad estimation. Why don't we narrow it?
Would it be 32?
You want to say 32 billion? Okay. Does anybody else got a problem with 32 billion?
That's a lot of million.
It's a lot of million.
Two times.
All right, let's say 32 billion. Okay. Because it said estimate, so, you know. 32 billion. Okay, so let's go on to Model 3. So in Model 3, we have two tables. We have the average mass of a single particle. We have the average mass of 1 mole of particles. So look at the table. What number in each element box would a chemist use to find the values in the average mass of a single particle column? So where do we look to find those numbers? No, I mean, if you didn't have that table there, where did they get those numbers? Maybe that's a better way to phrase the question. Where did they get those numbers from? Periodic table. Exactly which number on the periodic table? The atomic mass. Okay, so yes, so that's what you would put for number 12. That's what we're talking about in the element box. The element box on the periodic table, that should have been put in there, but a better way to phrase that question. So, yes, it is the atomic mass. How is the mass of a single particle changed to get the mass of 1 mole of particles? Well, they did something. Look at these two tables. What's different about them? Pretty much just substituted grams for atomic mass units. Yeah. They changed atomic mass units to grams. They're the exact same number. We just changed it from atomic mass units to grams. All right, so number 14. Which sample contains more atoms? 18.016 atomic mass units of water or 18.016 grams of water? Are they the same thing?
I think it's grams.
Is grams more? Why would you say gram? Because it tells us to explain. Why did you choose that the grams would contain more atoms?
Well, because it just seems like atomic mass units is on a much smaller scale compared to grams.
Grams is a bigger unit. Yes. Okay. Grams is a bigger unit. So if you think about a gram is about the weight or mass of a paperclip. Okay. So if atomic mass units and grams were the same thing, it would be pretty rough on you when you jumped into a swimming pool. You would be crushed. Think about the amount of water that's in there. Okay. So obviously, they're not exactly the same thing. Okay. An atomic mass unit is a unit of mass on a much smaller scale than an actual gram. Okay. So the gram would contain more atoms because it is a larger unit. All right. Now, a lot of times we like to just skip over that and we just say, oh, they're the same thing because they're the same number. And that makes some things easier, but in reality, that's not necessarily true. An atomic mass unit is a teeny tiny unit of mass on an atomic scale. How has the mass of a single particle changed to get the mass of 1 mole of particles? What did we do to get this to this? What do you think? Oh, did we already ask that question? We did. We already answered that question. Sorry, I'm not writing the answers and I'm forgetting where I'm at. Number 15. If the formula mass for iron 2 sulfate, and I gave you the formula there, you can see why it's important for you to know your formulas and your names because they're not always going to put that in parentheses. When you get to AP, they don't put that in parentheses. They expect you to know that iron 2 sulfate is FeSO4. Okay? And vice versa. So if that's the formula and the mass of that is 151.9 atomic mass units, that means we took the mass of iron, we took the mass of sulfur, and we took the mass of 4 oxygens and we added them all up, and that gives us 151.9. What is the molar mass of iron 2 sulfate? What is the mass of 1 mole of iron 2 sulfate? 151.9, exactly. So all I do is I add up all the mass of each atom, and that's, so 1 mole is going to be equal to 151.9, but we don't say AMUs, we say grams. Because the molar mass is the mass in 1 mole, which is in grams, not atomic mass units. But as far as what you do mathematically, you do the same exact thing. Add up the mass of the iron, add up the mass of the sulfur, add up the mass of 4 oxygens. So that's it. Pretty easy, okay? So use the periodic table to calculate the molar mass of ammonia. So y'all do that right now. And I'm going to give you just like a minute because it's not that hard. So tell me the molar mass of ammonia. The mass in 1 mole of ammonia. Y'all are going to get lots of practice on this. Just like you got lots of practice on naming, you'll get lots of practice on this. Because this one of those things that's like super important. It's also really, really easy if you practice it enough. And don't. All right, so what'd you get? 17. How'd you get 17? Multiply 3 times 1 for the hydrogens. And what else? 14 for the nitrogen. And that gives us 17 grams per mole. And that's the way we write it. Grams per mole. All right?
Was it MOL or MOL?
The word mole is spelled M-O-L-E, but in chemistry's infinite wisdom from being sarcastic, the abbreviation for mole, M-O-L-E, is just M-O-L. I don't know why it's so hard to drop off that one last E, but that's the way they decided to abbreviate it. So, you'll see me just write M-O-L. That's what I mean. How would the number of atoms in 1.01 grams of hydrogen compare to the number of atoms in 63.5 grams sample of copper? All right, so look at those numbers. And the first thing you need to think about is, I know, remember at the very beginning, I said the sum up is to remember that 1 mole is equal to how many atoms? Remember that? That big long number, 6.022 times 10 to the 23rd.
Mm-hmm.
And 1 mole is equal to the atomic mass, or the molecular mass.
Mm-hmm.
So is 1.01 grams of hydrogen's atomic mass? Yes. So how many atoms would that contain? Let's set up a unit multiplier because that's eventually where we're going with this. So we're going to always start with what you were given, 1.01 grams of hydrogen. And in our unit multipliers, the point is to get rid of what you start with. So we're going to get rid of grams. And we want to eventually get to atoms, but I have no idea how many atoms are in how many grams. I don't know that. But I do know how many grams are in a mole. And I do know how many atoms are in 1 mole. So I can set up 2 conversions. So I'm going to go grams to moles. And then I'm going to go moles to atoms. All right? So if I look on my periodic table, in 1 mole of hydrogen, there is 1 gram of hydrogen, approximately. And in 1 mole of anything, there is 6.022 times 10 to the 23rd of those things. We can do this without a calculator. Come on. 1.01 divided by 1 is basically 1. 1 times 6.0232 times 10 to the 23rd is 6.022 times 10 to the 23rd. So how many atoms are in 1.01 grams of hydrogen? 6.022 times 10 to the 23rd atoms. Okay? All right? Do the same thing for the copper and see what you get. Set up the same unit multiplier. I'm not going to erase it, and I'm not going to write it down for you. I want you to do it on a piece of paper. Set up that same unit multiplier, but for copper, and see what you get. A lot of the practice problems that you're going to do, I suggest you do them on paper, take a picture, and submit the picture. It will probably be easier than doing them on a Google Doc, or maybe even easier than using Tammy. I don't know. Whatever you feel comfortable with, you are going to be doing a lot of unit multipliers. Okay, so however you feel comfortable doing those. But I have to see the little train tracks, I have to see the little boxes, and I have to see where you cancel things out. Okay?
What does it say? Like, it's 1 MOL. What is beside? I can't really.
H, that's an H, and then I canceled it out. So when we're doing these, I would have, for me personally, and when I work these out, I like to cut a piece of paper out and a good old fashioned handheld calculator. It makes it go faster for me, but then again, I'm old and I'm just doing it. Anyhow, you will have quite a few of these to practice on. You'll have to check the due date. I can't remember. All right. Okay, there's a problem like that. In 1 mole of copper, is there 1 gram of copper? 1 mole of anything is always equal to its atomic mass. So you need to look up the atomic mass of copper.
Okay.
Remember, 1 mole of something is equal to that thing's atomic mass. 1 mole of something is equal to 6.022 times 10 to the 23rd atoms. Nope.
Oh.
Nope. Oh.
Oh.
Oh, what, Bentley? Oh. you have your units in the right place, but your numbers are upside down. So switch those numbers. The one goes on top. 1 mole is equal to that many grams,
Oh.
not that many moles equal to 1 gram.
Is the Wi-Fi option?
Wi-Fi evidently maxed out or something. It's not super slow. So,
I did this
did it
right.
come out to the same thing?
You did what I did, so.
No, you're not wrong. I just can't tell
One
what's gonna go
mole.
right there.
1 mole of anything is the atomic mass, okay? So it says. Instead of 1, it's the atomic mass of carbon. So then we lost that
So-
carbon.
What are you gonna put right there?
But yes, that
Grams
is
of
correct.
copper. All right.
That's what I
And in 1 mole
But I
of
was afraid
copper,
that was.
how many grams?
Well, I thought it was like, I had in the not the first one, but the second one, I had 1. So,
All right, I'm gonna put the rest of this up here just because I'm lacking in room. When you're doing these unit multipliers, you always start with what you're given. So 63.55 grams of copper. I'd like to do my units first because that helps me keep the numbers straight. I want to get rid of grams, and the only thing I know about grams is to go from grams to moles. Okay? And then, but that's still not going to give me what I want. I want atoms. So I do know how to go from moles to atoms. All right, then all my units cancel, so I can put in my numbers. In 1 mole, I look on the periodic table, and it's 63.55 grams of copper. That's the atomic mass of copper. That's how much is in 1 mole. And then I also know that in 1 mole, there's 6.022 times 10 to the 23rd atoms. Or it could be 10 to the 23rd of anything. It doesn't have to be atoms. But so 63.55 times 1 is 63.55. Divided by 63.55 is 1. And 1 times 6.022 times 10 to the 23rd is 6.022 times 10 to the 23rd. So how would the number of atoms in 1 gram sample compare to the number of atoms in a 63.5 gram sample of copper? They would be the same number. They are the same number.
That just seemed too easy.
so that's not gonna be like that for everything. So do we make the 7?
Yes.
I'm sure there's gonna be one of them where the number that we get.
Exactly. Now your numbers that you're given are not going to always be the atomic mass. Okay, but this is just to kind of introduce you and show you that you can go from grams to moles and moles to number of atoms or molecules, if that's the case. So 1 mole, make sure you star this or highlight this or something because you need to memorize that. I will not be giving you that information. 1 mole is 6.022 times 10 to the 23rd. You have to memorize that number. 6.022 times 10 to the 23rd is equal to 1 mole. Okay? This number is called Avogadro's number, named for Amadeo Avogadro. So fill in the blanks. Using the periodic table, be sure to indicate units of grams or atomic mass units on all masses. So 1 atom of helium. Now we're just talking about 1 atom of helium is what mass? From the periodic table. 4.0 whatever. Is it grams or is it atomic mass units? Atomic mass units, because we're just talking about 1 atom. 1 mole of helium contains
6.022 times.
There we go. It asks for the number of them, not the mass. So the first blank is the number of them. It contains 6.022 times 10 to the 23rd. And then it has a mass of for what? Grams. There we go. Formula unit for calcium chloride has a mass of.
Oh, you have to add.
Add them all up. So you got to look up the mass of calcium, which is 40, I believe.
Yes.
There's 2 chlorines. Those are 35 apiece. So we're looking at 40 plus 70, which is 110. Now we're talking about a formula unit. So are we talking about grams or atomic mass units? Atomic mass units. Okay. And 1 mole of calcium chloride contains how many formula units? 6.022 times 10 to the 23rd. 1 mole of anything is 6.022 times 10 to the 23rd. If I have 1 mole of donuts, how many donuts do I have?
Oh, that's a lot of donuts.
That's a lot of donuts. 6.022 times 10 to the 23rd. If you watch the Engage video, it tells you exactly how many donuts that is. And it is a lot of donuts.
So how do you know when to put, I know it's not like AMU and
Okay, that's a good question. When you're referring to moles of things, it's going to be grams. When you're referring to an individual atom or an individual molecule, you could say AMUs. So what would be the mass of 1 mole of calcium chloride? $110 grams, yes. Oh, and that's the exact same page again. Well, I'll be. Look at that. Okay, extension question. Hang on a second before we move on to that extension question. I want to see what else we got on. Oh, we always have so much time in here. This is
So these videos up here, is that the part that we didn't get to do on Tuesday?
yes, that's the part you didn't do on Tuesday. Okay, so if you look back to, don't do it right now, I'm just showing you on the screen. The pre-AP chemistry unit 4.5 empirical formulas, that's an ed puzzle. That's homework. Okay, for Tuesday. It says it's due Friday, but I'm actually gonna I'm gonna change that. And then these practice problems are due Tuesday as well. And on the practice problems, I made a video doing a couple of examples. Okay, so you should know how to do them. It's the same kind of stuff we've done today. And then, so if you watch the video, the other thing to remember about that is you don't have to do all of them because there's like 50 on a page. I don't want you to do all of them. Okay, pay attention to the instructions. Show your work. If you do not show your work, you get 0 credits because I give you the answer. So show your work. You can show it on a piece of paper and submit the picture. However you want to do it, I don't care. I gotta see your work. Okay. All right. So let's go back and finish the extension
Are we
question.
gonna talk anything on the mole concept? Part of last
Yes, you will. There is a table. You're going to fill in this data table. Judging from what we've just done today with this POGIL, you can go back and fill this in. And then there's this data table that you'll fill in using the videos. Okay. There are questions. There's 4 questions right here that you will answer. And then I think that's it.
So all of those homework assignments are due Tuesday.
Yeah, everything's due Tuesday. I'll make sure that gets changed. Okay. I put that, I believe one of these things was due today, and I'm going to change that.
Yeah.
The POGIL is not due today. All right. So using the periodic table, answer the following questions. Fluorine gas consists of a diatomic molecule of F2. How many molecules of fluorine are in 1 mole of fluorine? You should have that in your memory right now. 6.022 times 10 to the 23rd. There's nothing you can calculate.
They come.
Because 1 mole is always 6.022 times 10 to the 23rd. So if they say 1 mole and ask for the number of things, it's 6.02. Come on, you're supposed to. Now I know why I did that. 6.022 times 10 to the 23rd molecules. We're not talking about atoms anymore. We're talking about molecules, so do your units correctly. What is the mass of 1 mole of fluorine gas? Be very careful. Let's see if you can get this. Be very careful. The mass in 1 mole of fluorine gas. Okay. Write it out. Write out your unit multiplier. And I'm not saying you're wrong. I just want you to write it. No, this is not the 6.02. Because I'm looking for mass. And I'm saying be careful because you got to go by the formula. Look at the formula for fluorine gas. What's the formula for fluorine gas? Is it just F? Or is it something else?
Do we do these train tracking?
Yep, you can do the train track things for that. All right, bathroom break time. All right. Okay, so we were on 19B, and I said to be careful. We want to know the mass in 1 mole of fluorine gas. Remember, fluorine gas is F2. Okay, so how am I going to how am I going to set up my unit multiplier? What am I going to do? I always start with what I'm given. So if you're like, I don't know, look at the problem. What are you given?
F2.
1 mole of F2. So that's where you start. That's the first thing you write down. 1 mole F2. What am I wanting to find? The mass of F2. So I need a conversion that gets rid of moles and gives me grams. So where are moles going to go? On the bottom. And what's going on the top? Units. I do units first. Grams. Because I know how to get from moles to grams, right? Mm-hmm. All right, so look, using my periodic table, in 1 mole of F2, how many grams are there? 38. How did you get 38? 19 times 2. And yes, it is. This is an F. It is approximately 38. Maybe red would be better to use instead. $38 grams of F2. Did someone just join in? Hello. I can't see who you are. Who is that? Corbin. Hello. So I need to see that your phone is off and that there are no other devices in your room. And then, all right. Okay, can you show me there's no other devices in your room? Real quick. TV's on, that's it. Okay. All right, so go ahead and sign in and just take the quiz. There is not a password for this particular quiz. Okay? And we are working on the lab, so when you're done with the quiz, you can hang around and finish up the lab if you need to, or this will be on video by the end of the day, so you can watch the video. Either way. All right, so here we are. So I get the 38 by looking at the periodic table. Fluorine has an atomic mass of 19, but I have 2 of them, so it's 19 times 2. Okay? And then I'm just going to do my multiplying. My moles cancel out, and I have 1 times 38, which is 38 grams of fluorine. Okay, how many atoms of fluorine would this be? Hang on. Now, you got to think for a second. You got to think for a second. I'm looking for how many atoms. All right. I have 1 mole of molecules. How many atoms are in each molecule? In this formula, how many atoms of fluorine are in each molecule of fluorine?
19.
Look at my formula. How many atoms of fluorine are in each molecule? 2. So would it be 6.022 times 10 to the 23rd?
It'd be double that.
It would be double that. So let's set up a unit multiplier, okay? Let's set up a unit multiplier. We know that 1 mole equals 6.022 times 10 to the 23rd. So I have 6.022 times 10 to the 23 molecules of F2. And in 1 molecule of F2, I have 2 atoms of fluorine. So I need to take 6.022 times 2, which is 12.04 times 10 to the 24. Or I'm sorry, not 12, 1.204 times 10 to the 24 atoms of fluorine. Okay, so I'm not sure where y'all at in math. I heard lots of X's and all that kind of stuff. And usually you're solving for an X, and that solving for an X gives you a number. Yes. Well, in here, don't give me just a number. Put the unit behind it. Okay? You're not going to get full credit if you don't put the unit behind it. So if you just tell me 1.204 times 10 to the 24, I'm not going to give you full credit. I'm going to be really mean, and I'm going to count some points off for your own good. Because later on, as we continue to build on this concept, putting that unit is going to save you a world of confusion. Okay? So write out atoms of fluorine. It's 6 letters. Okay? Take your time, put the unit. Okay? Otherwise, these numbers are going to not mean anything. They're going to get really confusing, and you're just going to make your life so much harder than it needs to be. Okay, the mass of 1 mole of lead is 207.2 grams. Use a proportion to calculate the number of lead atoms in a 15 gram sample. All right, it says use a proportion. Oh, but we're not using a proportion. Use a unit multiplier. That's what we've been setting up, which is sort of like a proportion, but I like to use the same terminology all the time. So, all right, so I'm going to let y'all do that one on your own, then we're going to come back together and go over the right answer. Or actually, here's what I'm going to do. I'm going to give you the answer, and you got to work backwards to show me the work. Okay? Because I know some of you will sit there and wait for me to give you the answer. So I'm just going to give it to you now. Because I'm more interested in your work. Because if you can get the work right, you can get the answer right. So 4.32 times 10. Oh, that's not 32. That's 36 times 10 to the 22. And you need to be within a decimal point. So, start with what you're given. You are given that you know the atomic mass of lead, and you know that you have a 15 gram sample. So now, tell me how many atoms are in that 15 gram sample. Okay, we'll start there. We have 15 grams. Okay? We want to know how many atoms are in 15 grams, not how many atoms are in 207.2 grams. That's just information in case you didn't have a periodic table. The actual question is the second sentence. Use a unit multiplier to calculate the number of lead atoms in 15 grams. So the question gives us how much lead do we have? 15 grams. That's where we start. The first sentence is just information.
So 207.
All right, so you have 15 grams. So put PB up there. I know you, I promise I'm not OCD, but it will take you right on. To have it. Okay, so we want to get rid of the lead, the grams of lead, where should we put lead? Right here. Yeah. So we get grams of lead here. So what do we know about grams and what were we given in that first sentence? Okay, so we know that in 207 grams of lead in what? In one mole. So we're going to put moles right there. Okay, and but my question doesn't ask for moles, does it?
Well, snap. That's not it.
Atoms. So what do I know about moles and atoms? There you go. So where's the moles going to go?
That's not it.
So they
What
can't
did you get?
move the moles.
1.871637 E plus 1.
That's not what I got.
What'd you get?
6.022 times 10 to the 23rd.
I got 7.06. Probably right. Definitely got it right for some.
Divided by what?
So like, let me see how you set it up.
How many grams are in one?
I obviously said that's wrong, so.
Well, yeah, obviously the two.
So you have 15 divided by 207, and then
See,
times the 6.022 times 10.
I did that, because in the question, it said, 1 mole of lead atoms is 207.
It's not.
Yeah.
So, it's 19 grams.
That's what I got. I got that. It's mine.
1 mole is not 1 gram.
A little bit, but
So you just don't divide it.
Divided by 207 times.
That's not it.
6.822 times 1022 grams. Go back to that. Let's start at 15. Then you're probably.
I'm just trying to.
yes.
Oh, you're putting times 10 times 10. Okay, that's-
So when I'm, okay, so when I'm
It's not fun, is it?
What?
We don't have to mind.
For simple mathematics.
I don't know how to put the equation in. I got it. I don't know. You used everything.
This makes zero functional sense.
Yeah.
That's not all. I don't want to put it in my.
6.02
Just
times.
start punching it, so.
Exactly. T.
I'm most likely.
That's what Ron would do.
That's what Ron would do, exactly. I was just saying,
What the heck?
I was gonna say, you just stick both like, in your pocket, and make it sleep.
Oh, yeah, I was out by 9.
Yeah.
Imagine going to bed.
Dude, I can bet like.
No. Okay, so
I
we
tried.
got grams down there. So if I want to get rid of grams, what has to go on the, get that number. Forget it's not even that.
The grams.
The grams have to go there, so put grams. And from the information on top, what do I know? Grams, how many grams are in there?
I got it.
Holy cow!
I got it before you.
You didn't
Hey.
solve world hunger or anything.
Pretty close.
You didn't solve the problem. But I'm glad you're trying to. Okay.
That's
no,
right. You
that's
multiply
right.
15 times that and
So,
divide it by that.
okay, look at what it says.
Because all that is a fraction.
207 grams.
We're just
Where's
topping it in.
207 gonna go? The size of the mold or above the mold? 5 grams.
Oh my gosh.
There you go. 207 grams is equal to
Oh.
what?
That's.
So it's on the top, it's.
Okay, so
Okay,
now
that's
you
what
can
I
If I was doing it right, I was multiplying times that.
Yeah,
Yeah.
on the bottom is 207.2.
Dude, I'm so. This is awesome. Yeah.
Okay, so I got one more.
Well, it's funny as you just type it in the calculator.
One mole,
So you just use
alright,
that.
alright. And
Divided by the bottom.
When did you get this?
I said, it's one mole is always equal to this number of things.
That's for
That's 206.022.
Yeah, Tuesday, Wednesday.
Okay. One.
Tuesday.
And put out.
Wow. So you can go check. No, he needs to.
That should be when you've done your, now make sure you can
I don't have
actually
any.
put that in your calculator.
Yeah, whatever.
Oh, are you talking about substrate? Yeah, I already told Bill after you graduated, getting all the time.
You can't put it in your
Pull
calculator.
over to my mom's car, pull over.
Okay.
I'm so mad.
You said, you gotta learn how to work with calculator. Alright, that's what we gotta do. So you need, so you're gonna put in 15 divided by 207.
Hey, you
So
can,
that's on the bottom.
hey, you can ask.
Calm down,
I have
Mom.
one. Oh, I have.
You're gonna multiply by what's in the top.
I have one.
6.022.
Kabamskis.
Actually, I have two.
EXP is gonna take the place of that times 10. Okay, so EXP now put in 21st.
Yeah.
That's right.
Nah, you-
Okay. That E is the times. Okay. Wow.
Maybe not.
But
I
if
won't.
you don't practice that, actually do it. Believe it or not, I'm prepared.
Okay, then, get it, she'll get one small.
One more thing.
If it's small, it's better.
Those are values on
Grams of lead. After we
Oh, snap. Yeah.
You know how, I think Friday of last week, how later on English, we were gonna like have this solutions on whatever we went over.
Yeah,
You know what I talked about?
yeah,
Is that today?
probably. What's up?
You know how I can
Calm down. Swap a nine.
Have you done
They're
any
moving
way?
perfect credit.
No, I'm filling in all the other tables, so I don't have to take a picture.
And I gotta do something.
I'll just take
It's not even gonna be that. It's gonna be.
21.6.022 times it.
You get this one right, this will be right.
I looked, I used to Google.
Right, so the bulk of your points will come.
You already had done yet?
No, I hadn't done it. She teaches how to do the first one related class.
What?
Right?
Man.
Alright,
Oh, I have 3 lessons.
questions, Did everybody get, let's see what you got. I know Zach got it.
And he explained it to us.
I actually already had it written down.
Yeah, I think you were already on the right track. So how did you explain it?
I just said
I mean, you said it was making
I
more
said
sense.
you
So.
multiply the top across and then divide by the bottom across.
Well, see, I put 15 instead of 207, but
You put 15 where?
on the bottom,
On the bottom.
Yeah.
Okay.
that's where I went wrong.
Okay. So, whenever you're given something or whenever you're relating grams to moles, you might want to write this down somewhere because it's one of those key cardinal rule things you could memorize. When you are relating grams to moles, it is always the molecular mass. Okay? It is never what you're given in the problem. So if you were given 15 grams, that 15 grams never goes in a unit multiplier with moles.
It's actually.
It's the actual molecular mass or atomic mass that goes in the unit multiplier with moles. Always. Okay? And then this is just what you started with. And a lot of times that's half the battle in these problems and in math problems. When you think about it, in a math problem, half the battle is figuring out what is it I'm actually trying to do. Okay? What am I given? Where do I start? Okay? So whenever they give you something in there where they're telling you 1 mole is equal to this, that's not where you start. That's just information to help you. Look for the actual question part, or the part where they're telling you do this. Use a unit multiplier to calculate the number of moles in 15 grams. So what they give you in that sentence, that's your given, and that's where you're at start. Everything else will be filler or information to help you or whatever. Okay? Okay. Does that make sense? There is one more question.
I feel like I have to answer it all.
All right, so let's look at 21. What is the mathematical relationship between the atomic mass unit and grams? Oh, let's think on that one. So, what's the relationship between a gram of something and an atomic mass units? They are bigger, but when I say mathematical relationship, I want to know, and according to what's up there, I want to know 1 gram is equal to how many atomic mass units? They're not equal. It's because a gram is bigger. So if it's a gram is bigger, they can't be equal, right?
How much would it take to 1 gram?
Yes, I want to know how many atomic mass units would it take to equal 1 gram?
You said like a lot, so I'm gonna go with
It's a lot. So
17,948.
yes, the only other big number that we've had in this thing is 6.022
Oh, that's what I was about to say.
Yep.
times 10 to the 23rd. Okay, 1 gram of something is equal to approximately 6.022 times 10 to the 23rd atomic mass units. Okay, not that question will ever come up on a test, but it shows the relationship. Okay, that a gram is related to the Avogadro's number of things by the fact that 1 mole is Avogadro's number of things, and 1 mole is equal to the molecular mass. Okay? All right.
That was a good day.
I think it was. I always have good days of chemistry in here with y'all, though.
We got
I very rarely. I have not had a bad day of chemistry.
It would have been better if
Never
we
had a
had
bad day.
been done with this now if we had got to come on Tuesday.
It would have been. Y'all would have been. Yeah, I know.
You guys have
But
to be okay.
technically, you could have done it Tuesday night. I mean,
Well, I watched the.
it was
I
there.
did the Ed puzzle and I was confused, so it was better off I didn't.
Do you want us to just take a picture of this and upload it to?
Yes, you can either, if you want to, as far as turning this in, you could turn in 3 things. You could turn in the student data sheet, the answers on the Cami sheet that you can just write in, and then if you want to take a picture of that and show me your other work, you could do that. If you decide to do that, please put a note on your worksheet somewhere to remind me to go look at the picture, because sometimes I overlook. Hopefully the Ed puzzle makes a little more sense now that we've done it. And so here's the Ed puzzle for tonight is empirical formulas. And then your 2 practice problems. I was going to change something. Oh, this. What was I going to change today's date? The Ed puzzle. I was going to change the due date on the Ed puzzle. That was it.
What's that video that you recorded just in case you for extra practice? Like to have to look over, like the video you just made.
Oh yes, I'm gonna post it. Yeah, it'll be in today's folder. Probably by lunchtime, because yeah.
What if I couldn't do the
Let's try it again. See if it'll work again.